Welcome to AI Frontiers. Today, we explore the latest machine learning breakthroughs from August 27, 2025, drawn from 48 significant papers in the arXiv preprint server's cs.LG category. In this episode, we journey from foundational theory to real-world applications, with a special focus on how reinforcement learning intersects with scheduling. Join us to discover, learn, and engage with the evolving conversation at the forefront of artificial intelligence. Imagine a world where your city's power grid, financial markets, and logistics networks are optimized overnight by learning machines operating tirelessly while everyone sleeps. Today's AI models predict, adapt, and make decisions at superhuman speeds. But how close are we to achieving fully autonomous, fair, and transparent AI? We'll examine the key breakthroughs enabling this progress and the challenges that persist, as we reveal the most exciting advances in machine learning research. Machine learning now underpins a vast array of modern technologies, powering everything from recommendation systems to autonomous vehicles. Progress in this field reverberates across industries, informs public policy, and shapes public trust. Each new development brings us closer to smarter, more equitable, and more widely accessible AI. The papers highlighted today provide blueprints for the next wave of innovation. As we spotlight both achievements and the remaining obstacles facing real-world deployment. To conceptualize the dynamic nature of machine learning research, envision it as a bustling, ever-expanding city. At its center stand the skyscrapers, core methodologies like neural networks and reinforcement learning. Surrounding neighborhoods address issues like fairness, scalability, privacy, and continual learning, each contributing unique innovations and challenges. Some areas, such as deep learning, progress rapidly, while others, like privacy-preserving techniques, evolve more quietly but with equal importance. Each research paper serves as a blueprint or a renovation, sometimes subtle, sometimes transformative, driving both theoretical and practical advancements. Theme 1 centers on robustness and generalization. Machine learning models must adapt to shifting data landscapes, much like a seasoned chess player adjusting to an unfamiliar board. Papers such as Distribution Shift-Aware Neural Tabular Learning and ALSA Anchors in Logit Space for Out-of-Distribution Accuracy Estimation advance the resilience of AI systems, equipping them with the capacity to recognize and respond to novel situations. Robustness is thus akin to street smarts for artificial intelligence, enabling survival amid unpredictable or messy data. The underlying technical focus is on generalization, the ability of models to perform effectively on previously unseen data. Theme 2 investigates fairness, interpretability, and trust in machine learning. Algorithms increasingly influence critical outcomes in domains such as loan approvals, employment, and the justice system, heightening the stakes for transparency and accountability. Tools like FairLoop and Delta-Audit enhance transparency and auditability, enabling stakeholders to identify and address biases. The goal is to ensure that AI systems function as fair and understandable decision-makers, similar to a transparent and accountable judge. The central technical concept here is interpretability, facilitating comprehension of model decisions. Theme 3 addresses the challenges of efficiency and scalability. As datasets and models continue to expand rapidly, the need for resource-efficient algorithms becomes paramount. Laura exemplifies this with its combination of sharpness-aware minimization and low-rank adaptation, while fast 3D diffusion accelerates the synthesis of granular media. Efficiency in this context is comparable to packing an entire library into a backpack, enabling powerful yet lightweight AI. The real-world consequence is the democratization of scalable AI, making advanced capabilities accessible beyond just large technology firms. Let's examine several key findings from this research collection. Hines et al. Demonstrate that reinforcement learning can dramatically reduce search tree sizes in scheduling, surpassing established industry standards. Delta-Audit offers precise identification of model changes, enhancing the safety and reliability of system updates. FinCast introduces foundation models capable of zero-shot financial trend prediction across diverse datasets. Bylora enables resource-efficient fine-tuning of large neural networks, and MobTech CISA empowers models to selectively unlearn personal data, advancing both privacy and regulatory compliance. Our highlighted paper of the day is by Hines and colleagues, who confront the classic combinatorial challenge of industrial scheduling. Their core insight is to model the search process as a multi-armed bandit problem, where each decision point is treated like selecting which slot machine to play. This approach leverages reinforcement learning to intelligently choose which branches of the search tree to explore, resulting in their Optal CP solver achieving up to 3.5 times the speed of the industry-standard IBM CP optimizer. The technical backbone is the multi-armed bandit paradigm, which balances exploration and exploitation. The impact of Hines et al.'s work is both theoretical and practical. Optal CP establishes new records in job shop and project scheduling benchmarks, improving the best-known lower bounds and effectively finding shortcuts in complex solution spaces. By releasing their solver to the public, they democratize access to state-of-the-art optimization tools. This achievement underscores the value of integrating reinforcement learning with established algorithms and delivers tangible benefits, saving time, resources, and operational complexity in industry settings. The researchers behind this breakthrough were motivated by pressing needs in logistics and manufacturing. Hines and colleagues set out to develop reinforcement learning solutions that are robust, efficient, and generalizable, bridging the gap between academic research and real-world demands. By releasing their tools, they empower both the academic and practitioner communities. This serves as a reminder that long-standing problems often require innovative perspectives and interdisciplinary approaches to drive meaningful progress. Looking to the future, the machine learning landscape can be likened to a thriving ecosystem, adaptive, resilient, and increasingly fair. Traditional boundaries between fields are blurring. Reinforcement learning converges with combinatorial optimization, and fairness considerations become integral rather than peripheral. Models are expected to learn continually, evolving without forgetting past knowledge. However, scaling robustness and fairness across global, heterogeneous datasets remains a formidable challenge. The analogy evolves from expert gardeners tending individual plants to wise forest rangers managing entire interconnected environments. To recap, today's episode navigated the cityscape of machine learning, delving into themes of robustness, fairness, efficiency, and tangible real-world applications. The featured work by Hines et al. Illustrates the transformative potential of reinforcement learning in classical optimization problems. New tools are making AI more accessible and trustworthy, while innovation increasingly requires a collective effort. Your curiosity and engagement play a pivotal role in shaping the future of AI. Explore the referenced papers, participate in discussions, and contribute to this ongoing journey. This episode was synthesized using GPT 4.1 with text-to-speech provided by OpenAI and image generation by Google. All content underwent review by a human expert to ensure accuracy and clarity. However, minor oversights may persist, so listener discretion is advised. Every referenced paper is cited for further exploration. Our commitment is to blend the speed and processing power of AI with the critical judgment and rigor of human oversight. Do not miss the next breakthrough in artificial intelligence. Subscribe to AI Frontiers now. This channel serves as your hub for rigorous, accessible insights into the latest advancements in machine learning. For deeper engagement, paper links and discussion forums are available in the channel description. Share your thoughts, comment, and help shape the technology that will define tomorrow's frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.